But in thermodynamics, this is the most important part that I want to discuss here in exam point of view. What is the heat of solution and how to calculate the heat of solutions. Instead of that one, we'll go with a heat of neutralization. This is about heat of neutralization denoted as a delta H. How to calculate the heat of neutralization? The heat of neutralization is when one equivalent of strong acid combined with one equivalent of strong base, it liberates certain amount of energy. That liberated energy called as the heat of neutralization. Means it is always a exothermic process. It is always a exothermic process. In exam point of view, I'll tell you heat of neutralization is a intensive property. It is an intensive property. And if you see units of this heat of neutralization, either it is coming as a kJ per equivalent or kilocalorie per equivalent. That is the heat of neutralization. And you know the value which is going to liberate here, that heat of neutralization may one equivalent of strong acid and one equivalent of strong base, the value it become a minus 57.3 kJ per mole or minus 13.7 kilocalorie per mole, right? And this is a only concept about the heat of neutralization. Ki one equivalent of strong acid should combine with one equivalent of strong base, and amount of energy liberated is called as the heat of neutralization. And these are the two standard value I have taken. These are the two standard value I have taken. Now let us go with one example here. I am having a strong acid called as HCl. I am having a strong base called as NaOH. Obviously, they together combining to form the salt and water. Form salt and water. If you want to see, we can see HCl can be written as H plus Cl minus. NaOH can be written as NaOH, Na plus OH minus. NaCl, Na plus Cl minus. Water, H plus OH minus. You can say these two get cancelled. These two get cancelled. What is that? One equivalent of acid is H plus, one equivalent of base is a OH minus. Combining to form here as a H2O. Instead of writing in this way, better we can write here as a H plus and OH can be written in the form of a H2O. So here, as they combining together and it form here as a H2O means one equivalent of strong acid, one equivalent of strong base. It gives this or water. So in this case, the heat of neutralization should be either minus 57.3 kJ per mole or it is a minus 13.7 kilocalorie per mole. Now I will go with one example here. Suppose if you want to write this one in the terms of units and all, we can write in this way also. One example I will give for you. Heat of neutralization, which one we are writing as a minus 13.7 kilocalorie, that should be into number of equivalent kilocalorie we can write, or that is equal to minus 57.2 into number of equivalent kJ per mole we can write. One example I'll show you instead of why we wrote this formula. One example, because Exam question we are getting based on that part only. कि, but on one side we are having a strong base, we are having a strong acid, we are getting a salt plus water, and this one they are asking the delta H, it should be in the kilocalorie. Let us go with example number 1. If 1 equivalent, acid 1 equivalent, salt 1 equivalent, the value of delta H in kilocalories minus 13.7 kilocalorie. Example number 2, suppose it is a base is a 2 equivalent, acid, strong acid also 2 equivalent. Obviously your salt will be 2 equivalent, but delta H you are getting 2 times of minus 13.7 kilocalorie. Example number 3 you can see. Suppose if it is a 3 equivalent, it is a 3 equivalent, obtain salt also 3 equivalent, and here delta H value 3 times of minus 13.7. Example number 4, very interesting. If this is a 3 equivalent and if it is a 2 equivalent, but among these two, this is a less quantity, means this will be called as a limiting reagent. It will be called as a limiting reagent. But a limiting reagent only decide the formation of product. The product should be here how many? Now 2 equivalent, and delta H is 2 times of minus 13.7 kilocalories. Right? So this is examples to remember. Acid should be 1 equivalent, base should be 1 equivalent. If any changes is there, find out the limiting reagent and based on that, get the value of delta H. But here, if if one of the acid or base is weak, means strong acid weak base or weak acid strong base. One of the acid or base, if it is weak or both are weak electrolyte, then heat of neutralization is always less than standard value. What is the standard value we used here? Minus 13.7 kilocalorie. Because some energy or heat is utilized, because some energy or heat is utilized in dissociation of weak acid or weak base. Example I'll tell you. Suppose this is a strong base and this is a strong acid. They combine together to form the salt and water, and we can say delta H equal to minus 13.7 kilocalorie, because both are the strong base and strong acid is there. But now instead of that, if we'll do one other example here, I will take the base is a strong but acid is a weak. It is a strong base, weak acid. It gives rise to salt plus H2O, but delta H value in this case is equal to minus 13.7 become minus 13.4 calorie. Actually, what the less than one, less than this value means, I'm not talking about this negative positive one. Just value check it. Minus 13.7 become minus 13.4. If you want to compare minus 13.7 to minus 13.4, minus 13.4 is a bigger or larger value. But I'm talking in terms of the number. Zero point 0.7 to zero point 0.4 means 0.3 kilocalorie amount of the energy was utilized. It was utilized to dissociate that weak acid or to dissociate that weak base. One more example I'll give here. Uh, One more example is, suppose NH4OH, ammonium hydroxide, it is a weak base. When it combined with the HCl, which is a strong acid, it gives rise to salt, NH4Cl, plus of H2O, and delta H value equal to now. See, base also weak, acid is strong, obviously less than that. So maybe I can say it become a 13 kilocalorie. That means 0.7 kilocalorie is the energy utilized to dissociate weak base, right? If both are weak, let us say the example, if both are weak, base also weak and acid also weak, this is a weak base, these are the weak acid. When both are weak, I will get the salt as a ammonium acetate plus of H2O, and delta H value in this case I am getting here as a minus 12 kilocalorie, means minus 1.7 kilocalorie amount of the energy was utilized to dissociate weak base as well as weak acid. But one exceptional case I will tell you, listen here. This is the exceptional case among all. This is a exceptional case among all. You can see, if you have the reaction of HF and NaOH, they combine together to form NaF plus water. In this case, your delta H value will be much bigger than the standard value. That means this value, minus 16.7 is a value. This number is more time, or it is more than minus 13.7 kilocalorie. Because in this case, hydration energy of fluoride ions is very small, and due to that, delta H value will be greater than the actual value of the heat of neutralization. So this is a just general explanation I give. Now we'll try to see the questions how they will ask in the exam and how to approach the answer for this one. See here, question is given in this way. If one equivalent of given acid if one equivalent of given acid is neutralized by one equivalent of strong base, then arrange them in increasing order of acidic strength. Ha, and it is a heat of neutralization given in kilocalorie, right? Minus 12.3. Hb minus 12.1. Hc minus 13.7 standard value. Hd minus 12.8. Increasing order of acidic strength we want. But for getting the increasing strength of acidic strength, I will tell you only one point to remember here. Key greater the number, greater the acidic strength. Number beta. Don't go with a negative and all. If you want to compare here, the larger value is minus 12.1. Just number I'm talking. So greater the number, Hc will have greater number. Then it will have Hd. Then it will have Ha. Then it will have Hb. But it is the order of acidic strength. Why? Because minus 13.7 kilocalorie is a standard value. Means it is a heat of neutralization obtained by reacting one equivalent of strong acid with a strong base. But now if one of the acid or a base is a weak, the value we are getting less than that. See, all are having less than that. 13.7, then 12.8, then 12.3, then 12. Less than that means obviously beta their acidic strength or basic strength, one of the strength is going to be decreased. So what to say here, as the acidic strength means larger value will have a greater acidic strength than the other one. So it is a directly by seeing we are able to answer it. But now question is there, how to solve it? Solving part is given here. One example, I am having a acid something called as a 2 molar 100 ml HCl is acid. It is mixed with 2 molar 100 ml of strong base. So strong acid HCl is there. Strong base NaOH also there. Both are mixed together. Then find the heat of neutralization obtained. Then they are asking calculate delta H neutralization of the reaction. How to get here? The first part, get the number of gram equivalent of HCl. Number of gram equivalent of HCl. Then get the number of gram equivalent of NaOH. HCl gram equivalent is given as a 2 into 100 by 1000 because volume in ml by 1000. Here also 2 into volume in ml by 1000. If you solve it, I will get 0.2 equivalent of the acid, and here also 0.2 equivalent of the base. And as we know, both are 0.2 equivalent means delta H of the neutralization is minus 13.7 into number of gram equivalent kilo calorie. Minus 13.7 into 0.2 gram equivalent kilocalorie. By solving, we'll get the answer as a minus 2.74 kilocalorie is the heat of neutralization. Same way, one more question is given for the calculation part, and it is given here key 2 molar of 100 ml of the acid is mixed up with 3 molar of 100 ml of a base. They're asking calculate heat of neutralization. Same way again, number of equivalent of HCl 2 into volume in ml by 1000, 0.2 equivalent. Another case, number of equivalent of base, that is NaOH, it is given as a 3 into 100 by 1000. I will get 0.3 equivalent. But among these two, we know that this is a limiting reagent and it will decide the uh, product obtained here. So in this case, what we can say now, heat of neutralization equal to minus 13.7 into number of equivalent kilocalorie. So minus of 37 into 0.2. So here also I am getting minus of 2.74 kilocalorie. But now We'll talk the question based on basicity of the acid. For example, I am having 2 molar of 100 ml sulfuric acid is there. It is mixed with a 4 ml of 100 ml NaOH. Calculate heat of neutralization. So what to do? First get the number of equivalent of sulfuric acid. Actually molarity to volume in ml by 1000 into number of replaceable H plus ion here 2. So 4 by 10, 0.4 equivalent of the acid. Then number of equivalent of base 4 into 100 by 1000, it becomes zero point 0.4 equivalent. Then among these two both are same means we can say now delta H of neutralization is what is that? He minus 13.7 into zero point 0.4 equivalent kilocalorie, right? So this one we are getting as a minus 13.7 into zero point 0.4 because both are having same thing value. So answer I am getting here as a minus of 5.48 kilocalorie, right? So whatever the value they give here, first try to convert into the number of equivalent and multiply with this one. We are able to get the heat of neutralization.